Accurate quoting all begins with an accurate cycle time estimate. Unless you accurately know how long it's going to take to manufacture a part in your shop, it's impossible to send off an accurate quotation and estimate to your customer. In this video, we'll illustrate our KipwareCYC cycle time estimating software. We'll illustrate how the software works and go through some scenarios and profit and loss between guesstimates and actual cycle time estimate. Our sample part is made of 6061 aluminum and is pre-machined to the length and width 7.5 by 4.5. In the cycle time estimate, we'll use a Haas machine to face the top, rough and finish mill the 2 pockets, and then spot drill, tap drill, and tap the 9 holes. Before we begin, what's your guesstimate? How long do you think it will take to machine the part? Okay, if you've got your time, let's create a real cycle time estimate using KipwareCYC. From the main screen in CYC, we'll first select the estimate specific screen, and we'll input some reference information for the part to be estimated. Now we can start to create a cycle time estimate. Basically, the process is stepping through the part, operation by operation. We'll start with operation number 1, which is to face the part. We'll pull down our machine and select it from the pull down menu. We'll pull down our aluminum for our material, and then we'll input the rough milling, face milling with carbide inserts, and an operation description to face the top. Next, we'll put in some operation specifics. Our handling time might be the time that it takes to load the stock into the vise. Our tool diameter is 2 inches and 4 flutes. The next input we require is the length of cut. To help us determine the length of cut, KipwareCYC includes our cut length calculator. The cut length calculator makes calculating the length of cut quick and easy by using fill-in-the-blank forms. In this face milling menu, we'll input the specifics for our face milling operation, hit the calculate button, and the software will calculate the length of cut. We can then copy it to the clipboard and input it into the form. With our length of cut and cutter specified, we select the calculate button, and the software will go through and calculate the RPM and feed rate and the time required for this operation, including rapid time, tool change time, handling time, and the cutting time. Now it's basically a process of going through the part operation by operation. Operation number 2 will be our end milling operation to rough mill the 2 pockets. We'll use a 3/4 inch 2 flute end mill. We'll pull up the cut length calculator again, this time using the square rectangular pocket form. We'll input the specifics about the pocket that we're going to machine, select the roughing operation, and get the length of cut. We'll double it because there's 2 pockets. Once the form has been completed, software will go through and calculate the RPM and feed rate to rough mill the 2 pockets. Operation number 3 is our end milling operation to finish mill the 2 pockets. This time we'll be using a 3/4 inch 4 flute end mill. We'll pull up the same square rectangular pocket form, but this time select finished wall and floor only. We'll get the length of cut and double it for the 2 pockets. The software will record 0.46 minutes to finish mill the 2 pockets. Operation number 4 will be our spot drilling operation. We can easily figure out the length of cut by determining how deep we'll go for each hole and multiplying it by the 9 holes required. Software will go through now and calculate the speeds and feeds for drilling and 0.23 minutes to spot drill the 9 holes. Operation number 5 is the tap drilling operation. Here we'll use the cut length calculator to determine the length of cut. We'll use a peck drilling operation and describe the specifics of the hole that we want to drill. Get the length of cut, input it into the form, and then calculate the cycle time for the drilling of the 9 holes. Our last operation is the tapping operation for the 9 holes. Again, we'll use cut length calculator's normal tapping form to determine the length of cut and calculate the cycle time for the tapping operation. With all the operations calculated, let's take a look at the totals. In the View Operations screen inside of KipwareCYC, we can see the complete estimate. We can view the high time operations and even perform what-if scenarios by maybe changing the depth of cut or the tool diameters to obtain the real cycle times. The key to accurate cycle time estimating is simple. The speeds and feeds used in the estimate must be as close as possible to the actual speeds and feeds that are used on your shop floor. KipwareCYC ensures that happens. KipwareCYC has the feature to auto-create routing sheets. Route sheets contain all the estimate data, the complete machining process, speeds and feeds for each of the operations, and the times for each operations. These route sheets can then be sent to the shop floor so the setup or programming personnel have real targets to meet when setting up for machining. In addition, cutting condition feedback from the shop floor can be used to adjust the CYC cutting parameter database information. With that real feedback coming from the shop floor, the more you use KipwareCYC, the more accurate it becomes. Now let's take a look at some of the guesstimates and how they fare against the actual cycle time. Our client has asked us to quote 175 pieces. Some of those educated guesstimates might look like this. Let's say the estimate was 5¼ minutes. With the guesstimated cycle time of 5¼ minutes, for 175 pieces it would take us 15.31 hours, based on 100% labor. The actual CYC cycle time was 7.53 minutes, giving us a total of 21.96 hours. The difference between the guesstimated labor and the actual labor was 6.65 hours. If you charged $85 an hour for your machine's hourly rate, you would have lost $565.46. If you charged $65 for your machine's hourly rate, you still would have lost $432.25. The list price of KipwareCYC is $495, so your return on investment was met with just one job. Let's go the other way. Let's say you overestimated and you guesstimated 10 minutes to machine the part. The guesstimated cycle time of 10 minutes, we've got 29.17 hours to make 175 parts. The difference between the guesstimated labor and the actual labor, 7.21 hours. At an $85 hourly rate, you overcharge the customer $612. At a $65 hourly rate, you overcharge the customer $468. Most likely, your quote was too high and it was rejected. Again, with a list price of $495, your return on investment was met with just one job. Quoting and estimating is the lifeblood of your business, and accurate cycle time estimating is the beginning of accurate quoting and estimating. It's time to stop winning unprofitable work and start winning profitable work.